ZigBee is a protocol. XBee is the hardware that runs it. Those are not the same thing, and the difference matters before you configure a single setting or connect a single wire. In the next 3 minutes, that distinction becomes clear. ZigBee is a wireless communication protocol specification. It defines the rules, how devices discover each other, how they form networks, how data is routed, and how power is managed. Smart building lighting systems, industrial factory floor sensors, large-scale home automation networks, all ZigBee. Now, what is XBee S2C? XBee is a family of wireless radio modules manufactured by Digi International, a well-established range used across hobbyist, academic, and industrial applications worldwide. The XBee S2C is one module in that family. It is a small printed circuit board with an antenna, radio hardware, and programmable firmware. Something physical, something you connect to a microcontroller. What makes the XBee S2C particularly capable is its flexibility. This single module can run ZigBee firmware, making it a ZigBee device. It can also run DigiMesh, Digi International's proprietary mesh protocol, or basically IEEE 802.15.4 transparent mode. The module is the hardware platform. The firmware defines how it behaves on a network. Throughout this series, we work with the XBee S2C. If you are using a different module in the XBee family, the ZigBee principles are identical. Always refer to your specific module's datasheet for configuration details. So, the relationship is this. ZigBee is the operating system. XBee S2C is the device that runs it. You do not purchase ZigBee. You purchase an XBee S2C module, load ZigBee firmware onto it using XCTU software, and the result is a fully functioning ZigBee device. The protocol defines the behavior. The hardware executes it. Same network, 2 different layers, 2 different names. Now you know the difference. To get started with XBee S2C, you need 4 things. 2 XBee S2C modules. One becomes the coordinator, one becomes a router or end device. You need at least 2 to test wireless communication. A USB XBee adapter for each module, sometimes called an XBee Explorer. This connects the module to your PC so XCTU can configure it. A microcontroller, Arduino Due or ESP32. And XCTU software, available free from Digi International's website. That is your complete starting point. One physical detail before you prototype. The XBee modules uses a 2mm pin pitch. The spacing between each pin is 2 mm. Standard breadboards and most through-hole components use a 2.54mm pitch, also called 0.1-inch spacing. Because of this mismatch, the XBee cannot seat directly into a breadboard. Forcing it will not work. The solution is an XBee breadboard adapter, sometimes called an XBee breakout board. This is a small PCB that accepts the XBee module on its top surface and breaks out all the module pins to standard 2.54mm header pins on its underside. Those pins slot cleanly into any standard breadboard. In this series, we use dedicated XBee breadboard adapters, 1 per module. Without this adapter, prototyping on a breadboard is not possible with the XBee S2C. ZigBee is the protocol. XBee S2C is the hardware that executes it. That is the foundation of everything in this series. The next video is about XCTU, the software used to configure your XBee modules into coordinator, router, and end device roles. Not only that, by the end of this video series, you will learn a technique for designing and developing a multiple sensor data transmitting and decoding protocol for simultaneous sampling iterations based on the ZigBee protocol. Subscribe so you do not miss it when it drops. Which XBee module are you working with or planning to work with? Leave it below. I read every one.